Okay, so in this workshop, I'm going to give a demonstration of the techniques that I'm using with clients to get much more precise in specifying the overall workflow, but in particular, specifying what we want the AI models to do. And this all comes down to this thing that everybody's talking about called systems thinking. And to give us a background, I'm saying that the AI tsunami is coming, and a lot of it's not so much that the jobs will go away, but the tasks. So a lot of tasks will be replaced so that there will be a new way of operating. And I'm working with my clients to help them understand what they need to do to not be taken back by the tsunami, but to be the guy floating on top, not just surviving, but thriving. And it comes down to these four skills that I talked about in my earlier workshops. And what we're talking about here is at the bottom, you need to be able to specify your business processes very precisely. And the tool that's used for that in most parts of the business is business process management notation. And this allows us to specify business processes extremely precisely using diagrams. Once you've got your business process specified, then the skills kick in where people are making automations, either using their experience with spreadsheets and actually using spreadsheets to automate, or using their spreadsheet knowledge to build no code applets using the no code tools like Notion and Coda and Airtable and so on. And now the new thing is people are saying we can just write the code by doing vibe coding. But no amount of AI vibe coding magic will overcome the fact that you need to be very clear what your data model is, what your logic, your business logic is going to be, and what exactly the workflow is going to look like from the point of view of a customer or an administrator or somebody who's using your system. So we build our data models using tables. We build the logic by using formulas or by representing the logic in a formulaic way to the AI. And we assemble our workflow using user interface items because customers and bus drivers and people working in warehouses and administrators in offices still need to be able to interact with the system using some kind of user interface. The other skill that business managers have is the knowledge base. The AI is going to need to understand how our business process works using the documents that define our policies, our procedures, our processes. And this is what allows us to build AI agents. But in order to build AI agents, you still need to be able to say, here's the tables of the data, here are the formulas that help us do the logic, and then formulate that into prompts. And what I've discovered is that people who are moving into no code and then into AI agents, they can hit a wall fairly early on where intuition and spreadsheet thinking isn't entirely enough. And they end up with a lot of business processes where there's still a huge amount of copy and paste and not as much automation. And the way we've been able to overcome that is to train people in the area of systems thinking. They need a set of tools that help them think clearly. When I first came across these tools many years ago, it felt like somebody gave me X-ray glasses. I could suddenly look at business problems and look at business processes and look at complicated things that were going on in the world and the logic. And I had a way to think clearly and to write that down. So they were tools of conceptualization. It also meant I could communicate with other business managers very precisely, and we could collaborate with precision. And what goes for the humans you're interacting with also applies to the AI as well. If you can communicate precisely with the AI, you have a much better chance of getting what you're looking for. So with these tools, we can build very precise specifications and use those to help makers build exactly the app we want, or use those specs to help the AI vibe coder build precisely the code we want. And we can also use this approach to be able to add exactly the AI agents we need to our applications. And so for this workshop, I'm going to use a case study based on a hardware operation here in the Aegean Islands, where this started off as a small hardware store on one of the islands, and then they opened up warehouses in several islands, and they very rapidly became the number one supplier to builders and plumbers and carpenters and shipwrights and so on all across the islands. And the way they did that, they tried all kinds of online applications. They got themselves a website built, but it never quite put into practice exactly the way they wanted it. They are using a stock control application that's very good at making sure they have the right stock all the time based on how much of it they're using. But they had a very unique order process. And so the solution ended up being built on Coda. And what was unique about them was that the two brothers who are the owners and their wives, who do all the stock control, discovered that what builders and tradespeople and carpenters and plumbers really want is to be able to simply phone in a requirement and have somebody drive out to wherever they're working with the materials they're looking for. So they ended up with lots of warehouses across different islands using their own sons and daughters and nieces and nephews and so on to run the warehouses. And they engage a population of drivers locally who are independent. They own their own vehicles and they get a commission for delivering the goods. So their real problem is, how do we get the orders in from our customers and then dispatch those orders to the drivers and have the drivers arrive on time? So each of the stores, they have lots of locations. On the big islands, they have several, and then on one or two that cover the smaller islands, the Greek islands, they have lots of materials, lots of equipment, lots of tools. Basically, they have everything that the tradespeople could possibly want. And they offer a service where you either log in with your mobile phone and tell us what you want, or you phone us and tell us what you want, and we'll then organize the transportation. So the independent drivers are using trucks and 4x4s and vans and jeeps because the islands are fairly rugged. So getting to the different places, and they even have independent boat owners who will bring the material across from one island to another. So all of these independent drivers have a defined territory. So when an order comes in, we know which territory, which region, which location the order is to be delivered to, and it's assigned to the driver on that basis. And then the drivers will then go to the appropriate warehouse, load up with the materials and send it in. So they have a fairly unique sales process that wasn't available on Shopify or any of the off-the-shelf solutions. So they do have websites, they do have mobile apps. Nobody uses them, not very often anyway. People who are out in the field delivering work to their clients are not going to open up a laptop and start placing orders. Instead, they phone up for advice. What's the latest in the plumbing line for doing this? I have an electrical system to put in. What's the latest advice you can give me on air conditioning or whatever? And they use the phone to get advice and to place the order. They're all buying on credit. They get invoiced monthly. They can return any of the blocks they don't use and any of the slates and pieces of wood they don't use, but there's very strict credit limits based on their history. So the customer talks to an expert. The expert, who's walking around inside the warehouse doing other things as well, has a mobile version of the app, and they manage to place the order. And then that goes to another system where a warehouse operator does the picking of the materials, and then the driver gets notified and they will pick up the materials and head off, usually with many orders at a time. There's a system they use for optimizing the amount of trips that they make, and then they deliver the orders. There's no cash, there's no paperwork, and we use mobile phones for tracking who's where and what's happening. And they will collect returns and bring those back to the warehouse. So it's a fairly unique business that has a fairly unique workflow. And so we had to build something for them. And the first time they tried to build it, the developer got completely lost in all the logic because they didn't have the tools for conceptualizing and understanding precisely what it was that needed to be built. So the process that I use with them is giving them the tools they need to think clearly about what their process is. And there are three tools. You're going to build a data model that says, here's all of the things we want to model inside our system. So the task is to take what's going on in the real world and model it inside the computer system. And it doesn't matter whether you're using AI or not, you're using a computer to model what's happening in the real world. And the closer you make the model match what happens in the real world, the better it will be. And then from that, we can start to build what is the user interface, what is the workflow, who logs in, what do they see, what do they click on, what happens if they press this button, and so on. And then out of that, we then also need to specify the business logic. How is an invoice generated? How is the delivery managed and controlled? So let's start with the data model and take a look at what goes on, and then we'll go and look at the UI model and do a bit more work on that. So I'm going to switch over to an actual demo of what all of this looks like in the tool that I'm using. And so hopefully you'll get some sort of an idea of what it looks like in the real world. So switching over now to, I'm using the no-code tool Coda to build this, but in fact, this will work no matter what sort of a tool you're going to deliver in, whether you're delivering with Notion or whether you're delivering with Airtable or vibe coding or whatever. So the object model is a table. We call it the matrix. And each row in the table represents an object in the real world. So the first task is to ask a series of questions. What are the real world objects that are happening in the business that we need the computer system to track? So the first level is the system. The system has links to each of the users in the system. We represent user types or roles using capital letters so they stand out. So we have clients, we have administrators, and we have drivers. So here we see in the diagram in the object model, the system, and this arrow means one to many. The blob is on the many side. So each system, so the whole system has many clients. It will have multiple administration people, which I've spelled incorrectly, but anyway, and multiple drivers. And then we start to look at, okay, let's look at clients. A client is associated with many orders and is associated with many addresses. So again, in the diagram, that clients have multiple addresses because they can be working on different sites at different times and have their goods delivered to different addresses. And clients will also have multiple orders that they have placed. So there's an arrow that goes down here to the orders. That also means that every order is connected with a single client. So the arrows work both ways. So one client has many orders and each order has only one client. Similarly, every time an order is placed, based on the region that it's in, it gets assigned to a single driver. So the drivers get up in the morning and find that they have multiple orders to process. And then each order has lots of items in it, and each item will contain a product. And this very simple model is built up as we go through saying an order has lots of items, it has only one driver associated with it. Each order is also associated with a single administrator based on the region that the customer is in. And then we say, here's some of the details that we'll put in an order. It was placed on a given date, it was delivered on a given date, and it was returned possibly on another date. And so these data items are also listed in the table. So this object modeling is simply asking a bunch of simple questions. What is a product? It has a product ID, it has a price. You can tell that I use my mobile phone to put this in because I'm spelling things wrong. It has a piece of text that describes what sort of unit it's delivered in. Is it a bale of 20 blocks? Is it a 10-liter container? We need to know the weight of every product. And there's a flag to say, does it need special handling? Some products can only be handled by special things like forklift trucks or dumper trucks and things like that. And we start to build up an idea of what data items are in each of our objects. So a list of business objects, a list of how they're related, one to many to one, and we get a nice simple diagram. And if you hand this diagram over to somebody, an AI or a no-code maker, they can start to get a feel for what the database looks like. But also from this matrix, we can generate automatically what's known as an entity relationship diagram, a bit more detail. It's structured exactly the same as the object model, but it has more details. So for example, we see that drivers have links to multiple regions, links to the orders that they are going to deliver. Each order can then generate deliveries. So each driver is responsible for multiple deliveries. They have a name, they have an email, they have a telephone number. And we see that clients have a link to multiple orders. They also can have multiple addresses where they can have things delivered. They have a client ID and so on. These arrows then start to show us the links that we saw above. So here's the details for an order. Each order is connected with a single administrator. Each order is connected with, we've come up here, a single driver. Each order can be broken up into multiple deliveries. Let me try and see if I can zoom this diagram in a bit better. And each order has multiple items, and each item has a single product. It's linked to a single order, and it has a quantity, and then there's a discount percentage. So by having a conversation with the user or the manager of the process, I fill out this simple table, and based on the details I put into the table, I get an overall view of my database structure, and I get a detailed view of the database structure. And we're able to hand this diagram over to an agent and have it build the database, or you could hand it over to a no-code builder and they'd be able to build the database. And every object that's in the business process has its own table. And there are some rules we use as we're building this to make sure that the result is consistent. And I'll cover those rules later. And that's the object model. I'm going to pause for a moment. Any questions on that?
Oh, everything is clear.
Okay. So the next thing we want to do based on the objects, so once we've decided what the objects are and how they're related, we want to start working out who's allowed to make changes to what, who's allowed to add new rows, who's allowed to edit things, who's allowed to delete things. For example, we're saying that clients are allowed to add what? They can add addresses for themselves and they can create new orders. When they log in, they will see a list of their addresses and a list of their orders, and they can select from them. And when they want to place an order, one of the things they can do is they can go in and open up a search window and allow them to search the products. When you're searching a product, here are the items that we will use for the search criteria. You can search by the ID, you can search by the product text, you can search by the product type. And in the final production system, we actually add more things to it than that. But generally speaking, you start to define to the system what the search criteria are for a given object, so it knows how to build the search function. Administrators have a huge amount of functionality. They can add new clients, they can add regions, they can add products. Regions are broken into townlands for more detail. These administrators can open up new stores and they can create drivers. They can select them and they can do searches to look at people's orders. They can search for their clients using different criteria and they can search for products. Drivers, on the other hand, can only create deliveries. They can't create orders and customers or anything like that. They're just able to say, I'm going to deliver this on this particular day at that particular time. They can search the orders that belong to them, so they can find out what orders are in my region that I'm responsible for, and so forth. The result of filling out that matrix is this workflow diagram. Let's just take a look at what it means. It means that if I log into the system as a client, I end up in the client's screen, which is going to show me the addresses that I have, and it will show me the orders that I have, and it will give me a way to search for products. So it has three things on the screen that I can choose. So I can select an address and then edit the address, or I can click on a button that says, give me a new address, and I can enter in a new address. I can search for products in the product catalog. I can select an order and look at the orders and see the items. Or I can say, I want to create a new order. And when I'm in the process of creating a new order, I can say, create a new item, or and when I create a new item, I can say, I'm going to search for the products. And it takes me to the product search screen where I fill in the details and I refine my search until I'm happy that I've got the products that I want. And then it will add that. So I come to the product and I can add that as a new item to my order. So the logic for the workflow of the application is created using this diagram, and it's divided into the different user roles. So administrators have different things that they can look at, and the drivers have their own subset. So if I log in as a driver, I can search for a given order, and I can create deliveries, and that's about it. So drivers really don't have a lot to do, whereas clients have a lot, and administrators obviously have a lot more. So if I hand this specification to an AI vibe coding system, it can start to build a very accurate representation in code of what the application looks like. But if I hand this diagram to an ordinary maker who knows how to do things in Notion or knows how to do things in Coda, they can use the information in this diagram to build a working version of the workflow. So I'll pause there for a moment. Any questions?
Not exactly a question. This is everything orientated outbound, and inbound, the purchase of the materials at the warehouse. How
Okay,
is that
so the
going?
stock control part of this process is not defined here. I've deliberately, for this use case, only focused on customer purchase orders.
Okay.
That's because they don't use Coda for stock control. They actually bought a stock control system that they use, and this front end accesses the products using a product table, but the whole back end of measuring how much we've used of each product. We're using 16 tons of sand every week in the middle of summer, so we better make a reorder because it takes 4 weeks to get it delivered and things like that. So the stock control system is not part of this. Could be, and it would be a lot more complicated, but right now we're just focusing on the front end. Clients placing orders, drivers figuring out which orders to deliver, and an administrator being able to go in and create the new and manage the data that's needed for all of that.
Yeah, clear.
The next thing that we want to do is to work out what the business logic is. And for that, we use a thing known as a state transition diagram. And what we end up doing is we're saying for every object, we're going to have the object go through multiple states. And then we're going to indicate which are the legal or the valid transitions from one state to another. So when things go from one state to another, we have an arrow, and the arrow says, this is what we're doing. And then for every arrow, that is going to be a piece of functionality, either a formula or an action or a button or an AI agent that is responsible for mapping, for changing an object from one state to another. And to build the process model, we do another matrix where we we list all the different objects and what their states are, and then which transitions are allowed. And the system then takes that and builds all of the necessary logic. And the idea is that with just those three diagrams together, we have an entire and complete a specification of the application that we want to build. And whether we hand it over to an AI system or whether we hand it over to a no-code builder or whether we use it ourselves to build what we want, all we need are these diagrams, right? Here are the different objects and how they're related to each other. Here is the definition of the database tables that I need to build. It's slightly bigger, so I just... And with these, I've got a complete solution. So whether I'm drawing these up on a whiteboard or whether I'm using a tool like this to build them, these are the ways in which we can conceptually and clearly think about what it is we're trying to build. So in order for you to be able to do all of this, there are some very simple rules that you need to be able to follow. So if we come over here and look at the three tools that I'm talking about. So the data model is where you look at your process and you identify the business objects, and it will then provide you with a specification for all your database tables. When you start using no code first, it's easy to get into a bit of a mess as to what tables. Should I have lots of tables? Should I have only a few tables? And I see people writing directions and guidance to people saying, oh, you should have as few tables as possible. Adding more tables is making things complicated. And on the other hand, you have people creating tables when it turns out they don't need them. There is a simple three-step process for deciding which tables you need, and it gives you an exact answer. It's not magic, it's not a mystery, it's not bewildering if you know what the three rules are. So you identify the objects in your business process, and then you apply these three rules. The first rule is that each object, each collection of the business objects, like all your customers, all your products, all your orders, are represented by a table. And you need to put each object into its own table. How many tables do I need? It's usually determined by the number of objects that I'm trying to model in the process. So when you get to the stage where each table represents a collection of objects, that means that each row in your table represents a single object. In the spreadsheet world, you can have rows and columns and all that, but in no code and in vibe coding, you need to get down to very precise. Each row in a table represents a single business object. So there's a row for each customer. There's a row for each product. There's a row for each order. The attributes of the object, of course, give you the columns in your table. And here's the rule that we need to apply to have this optimized correctly. Each column should contain single values as much as possible. When you start building lists of things, you can run into problems. So if you put a list of things into a column, we really need to treat it as just a clever way of formatting text. If instead you're putting a list of things into a column and you really do need to process each item in the list separately, then you need to store them in separate tables. Because what you're doing is you're creating a new set of objects that need their own table. So single values for amounts and dates and all the usual stuff, text boxes, email addresses, all that kind of things are single values. And if you find yourself putting things in lists, you ask yourself, am I treating it as a single object, nicely formatted text, or am I going to do something with it and treat it as something more complicated? In which case, I need to build a separate table and put the items in that table and then link to that table. Similarly, when you have multiple options where customers can select different options, what sort of delivery mechanism do you want, or what status is a project task in, and so on. These are options where people have to select. You either put them in as a simple select list, but usually we end up putting them into a separate table. So we will have a table of task statuses. We will have a table of order status. We will have a table of delivery types, and then put a link to them. Because if you put them in as simple select lists, you can lose control over the management of them. Your administrator wants to come in and add more items to that table. You suddenly discover you need to create a new delivery type, a new payment type. It's better if you put them into separate tables. Sometimes we leave them as simple select lists because the no-code tools we use allow us to do that. But to be really precise and to future-proof your application, you're better off creating a separate table. And the other type of thing is when you have links from one table to another. If you have a single link to another table, that's what we call a many-to-one, and that's the usual and preferred way to link tables. Sometimes you'll have multiple links. You'll have a list of links to another table, and that's a one-to-many. And in that case, that's okay, but we need to worry about the performance. So we'll put them in, we'll build it, but we'll then watch out to see, does the performance degrade? Every time I add a new customer, is it spending a lot of time? Every time I modify a customer or modify an order, is it spending a lot of time handling these multiples? So the one-to-many links are optional. They're not required because there's a way of doing it where you put a link from the other table back to this one. So we make them optional links in that case. And then there's the situation where sometimes you have no orders or you have many orders. A customer might have no address, or they may be only allowed to have one address. They may have 0 payment types, or when they place an order, they have to put in 1 payment type. So this is known as 0 or 1, or sometimes you have 0 or many. We treat these when we're building our database as if it's one-to-many or many-to-one. We don't, generally speaking, make special column types for these types at all. We treat them the same as these links up here. And then our business logic may need to put something in terms of validation to say, actually, in this case, we will allow you to have no payment type until you place an order, but then you have to have a payment type. So rule 1 is simply saying that every object has a table, every object is a row in a table, and every attribute is a column. And as much as possible, we're going to avoid making complicated columns that have lists and lists, and instead try and have single values as much as possible. The second rule is that every item in the object, every item in the row, has to be dependent upon the row itself. So you don't want to put something into an order if it belongs to the customer, right? So when you create a new order, you want to put a link to the customer, and then the information about the customer resides in the customer record, not in the order. You don't want to put information about products into the customer table. They don't belong there. You create a separate table for the products, and every row in the product table has information that has nothing to do with anything else except that particular product. If you don't give unique IDs to everything in your database, you can run into problems in the future. So it's a good practice to give a unique customer number, product ID, order number to every item in your system, because unique IDs help the system to optimize performance and to guarantee that you don't get links that are crossed and going to the wrong items. All the items then, so if you create a product ID, then all the attributes on that table must be associated with that product ID and nothing else. If you have attributes that belong to something else, you need to move them to the owner of that particular attribute. So the customer email, I've seen places where people were storing customer emails on every order. You have to ask yourself, is that correct? Does every order for the same customer have a different email? Highly unlikely. So it's best to store the email on the customer record, and we think that's the correct way to go. There are exceptions, but generally speaking, every attribute should belong to the object it's sitting on, So the email doesn't belong on the order, it belongs on the customer. But then the order has to have a link to the customer in order to be able to get hold of that information when it's needed. And then the third rule is that, generally speaking, we try to avoid storing values that can be calculated, computed, or looked up. So can it be computed with a formula? We'll use the formula, remembering that data attributes in your tables that have a formula can never be modified by the user ever, because the formula determines what the value is. Sometimes you have the user take an action in order to calculate something and put the result in. So we will use an action or a button to store values using a formula. But in that case, the user can override it, overtype it, or change it, or an external data feed can come in. And this is, generally speaking, what we do with AI. Every AI column produces a result, but technically you could come back and overwrite that if it is necessary. So formulas can't be changed. The data is calculated and it's fixed then forever. It will recalculate if the values change. But if it's a user action button that sets that value, then it is the way to handle a situation where you want to set an initial value, here's your discount, and then allow the salesperson to override the discount because there's some particular reason why they want to do that. And the other computed value is when you look up data from other tables. Don't store data in your tables that can be looked up from other tables. So you look up a single table using a simple formula, returns a link to the row, and you use your dot notation to get the attributes. Sometimes you have to look up several tables, in which case you're building a complex formula that is a filter that joins several tables together to give you the values you want. So these three rules, each object is a collection, is a table, one row for every object. All the data has to be dependent on the unique ID for that particular object. And we're not going to store computable values. We're going to generate those as they are needed. These are the three rules that tell us how to build our tables. As we're building our tables, the other thing we have to concern ourselves with is the relationships between each of the tables. So sometimes you draw a diagram and that every customer has only one payment type, and you check with the business and they say, yep, every customer is only allowed to have one payment type. In which case you say, do we really need a separate table for holding payment types? Maybe payment type should be an attribute of the customer. So one-to-one sometimes tells us that we want to not have a separate table, but store it in the parent table. Sometimes you do store it as a separate table for future proofing. You might say, right now, each customer only has one payment type, but in the future, we may want to change that. So maybe you will do a separate table. But one-to-one is, generally speaking, redundant. You don't really need it. Where one customer, sorry, I'm going to go the other way. Every order has many items, and every item belongs to a single order. This is where you're saying we have a single link in our table. It is the simplest relationship, and it says every customer has one salesperson, or every order belongs to a single customer. Every driver has a single warehouse that they belong to, and so on. These are always the most important and the most essential links that are required. Where you have one-to-many, in other words, you've got a list of links, these are usually computed with a filter formula. So it says, here's a list of all the orders that this customer has placed. This is only safe to do if the other table, the order table, has a link going back. So whenever you have a one-to-many connection, you need to make sure that you have a backlink that goes backwards, and I'll show you that in the diagram. And this means that in a true relational database view of the world, these one-to-many links are optional, because I can always generate them on the fly by saying, select all of the orders where the customer ID is the customer that I'm currently looking at. The real thing I want to talk about is when you get a many-to-many relationship where you've got a list of links where multiple customers have ordered multiple products and multiple products have been ordered by multiple customers. If you try and implement it that way, you find you run into problems because these many-to-many connections appear to work at first, but you can't store any information about that relationship. And so we tend to regard those as errors. So when you see a many-to-many relationship, it usually implies that you're missing something. There's something between the customer and the product, because many customers can order a given product, but then each product can be ordered by many customers. So it's many to many. And you realize, oh, that's a sign that there's something missing. And what's missing is the order. You need an object called order because each customer can place many orders, but each order only belongs to one customer. And that breaks this deadlock of a many-to-many. So many-to-many is a bit like having an infinite loop in your logic. It doesn't work. You have to find a way to overcoming it, and you have to watch out for many-to-many. I've already taken you through the different diagrams, the object model, the entity relationship model, and the diagrams that I used in my demo. I'm going to go back to them now because I want to talk about where I've seen people have problems in the past. So in the object model, recently I had a case where people had built a solution for hiring candidates for positions in the company. So they decided they needed a table for candidates and a table for jobs. And then they decided they needed a table for the interviewing panels, and then a table for the interviews, the individual scheduled interviews between the candidates and the jobs. And then the first time somebody applied for more than one job, which didn't happen for about 6 months, but then somebody applied for more than one job, they suddenly realized we don't have a way of representing that because they had a one-to-one relationship between candidates and jobs. Each job could have many candidates, but each candidate was expected to only apply for one job. And then they discovered that if they needed to invite any of their candidates back for a second interview, they couldn't do that either with the system because the relationship between interviews and candidates and interviews and jobs didn't allow for the kind of reality where somebody gets called back for a second or a third interview. Not knowing how to build this model becomes a barrier, and eventually naive, no-code tool builders hit a wall where they're not able to think clearly about the relationships between objects. And this is why early on in the training up of people in no code or in vibe coding, you want to start to get them thinking in terms of each client has many addresses, each address belongs to each that relationship should be each address belongs to a single townland. Each region has many townlands. Clients will be able to have many orders. Each order has multiple items, but each item has only one product, and so on. Thinking clearly about this is probably the most powerful of the tools to have when you start trying to build solutions, either with vibe coding or with no code. And building the practice of asking users the necessary questions. Does your client have one address or do they have many addresses? Is a driver processing multiple orders, but are all the orders for a single region, or do we have drivers responsible for multiple regions? And in this particular case, we've said, yes, sometimes drivers across multiple regions. And just thinking clearly about these relationships helps you to define for yourself, for your colleagues, and for an AI system, a much better specification that helps you build a much better, more robust solution that will survive contact with the enemy when it is put into production. So those are the models and the tools that I wanted to cover. The use of these when it comes to building AI agents, essentially, it's best to think of these AI agents as users. What would a user do? What inputs does a user need, and what changes are they going to make, and what actions are they going to do? So you imagine a human doing the task, and that helps you define what the AI agent should do. Initially, I like to provide the agent with some sort of a user interface. In the end, it will be a set of prompts and a set of data values, but it helps to think of it, to imagine it as a human sitting down in front of a screen. What are you going to display? What are you going to allow them to edit? What buttons are you going to allow them to click to make changes and to produce actions? And think of it as providing a human with a form or a dialogue, a screen that they're going to use to do the processing. And that helps you think clearly about what are the data items that they need, what inputs do they need to provide, what outputs are they going to see, and what actions do they need to take. And so in the last step, you then replace all of this with the prompts that are going to make the agent do what you want it to do. And so at the end, you then convert it into your agentic objects. So each agent, in the process that I use for building agents, I put each agent into its own table. Each run of the agent is a single row, so it records everything the agent did so that we can audit it, we can test it, we can evaluate it and find errors. Each row will start off with some input columns, and then for every step of the agent's process, we'll have a formula that takes the inputs and the data that's in the tables, and it will build the prompt using the data from the tables or information from our knowledge base. The prompt will then go off to the AI and return the response. We found that it's very useful to make sure the response is well formatted in a good structured way so that we can process it when it comes back. So we ask for the result to be formatted in JSON or YAML or Markdown. That way we can handle the data that comes back in a formulaic, process-oriented way. And then when the response comes back, we can have another formula that will parse this structured response, extract the key items, update any database tables that need updating as a result, and then use the extracted key items to make decisions. What's the next step? Is it an error? Do I need to highlight this? Do I need to generate a message to send to one of the admins to say I've hit a snag? Or what is the next agent I need to pass this over to? So I've taken the customer order information, I have figured out what the bill of materials is, I now need to pass it over to a dispatching agent who can then figure out how to get those items packed up and dispatched to the customer, and so on. So for every step inside what the agent does, we have this simple 3-step approach. Build the prompt, execute the prompt, get back the response, and then execute a formula that then extracts the key items, updates anything that needs updating, and then decides what to do next. But all of these things still require us to have gone through all of the steps that I talked about here, where you need to have your 3 rules to help you convert your objects into tables. You need to then have an understanding and a very clear definition of what the relationships are between those tables. And then it helps to have a diagram that shows you what your object model is, your entity relationship model, and the user workflows. And I happen to use a nice matrix process for doing that, but you can do it on a whiteboard. You can do it using a piece of software that allows you to create these models and then export the final result as a JSON object that an AI object can take and use to produce the code if you're going to use vibe coding. And so that takes us to the end of what I want to cover in this workshop.